this is Gabble, and today I'm going to be talking about fuel cells. In this video, I'll be covering the what, how, and why of fuel cells. So let's get started. What is a fuel cell? The fuel cell is not actually a cell. The fuel cell is actually a battery pack that is renewable. The fuel cells only take in oxygen and hydrogen gas to make water, heat, and electricity. So compared to the traditional way of lighting a light or powering a car with fossil fuels and electricity, this is a much better option because using fossil fuels creates a lot of harmful byproducts. So knowing all of these, let's move on to how does fuel cell actually work. The fuel cell we're going to talk about today is called the monomer electrolyte membrane fuel cell, which is also called PEM fuel cells. You have to know 4 parts of these fuel cells before you get onto how it actually works. So the first part of this fuel cell is the anode and cathode. If some of you like batteries or chemistry, you'll probably know this, that traditional batteries have anode and cathode too. So anode is the negatively charged side of the fuel cells that will take in the hydrogen gas and conduct electron to an external circuit where it can make electricity. The cathode is a positively charged side of the fuel cell where it will take in oxygen and send it to a place where it can bond with the hydrogen atoms to form water, which is our byproduct. The second part that we need to know is called the polymer electrolyte membrane, which is just in the name. It's called PEM fuel cells. It's literally in the name of the fuel cell. So then you know it's a really key component for this fuel cell. The function of the polymer electrolyte membrane is to conduct the positively charged ions and ignore all those negatively charged electrons. So this is super key because that it can ensure that no electron will disrupt the process of making electricity and disrupt the reaction of forming water. This polymer electrolyte membrane can be as thin as the width of a plastic wrap to make the fuel cell super space efficient. The third component is the catalyst layer. The catalyst layer is made out of platinum particles and carbon layers. This layer is located between the PEM that we just talked about and the gas diffusion layer that we're going to talk about on both the anode, the negatively charged side, and the cathode, the positively charged side. The purpose of the catalyst layers is, on the anode side, is to separate the hydrogen molecules into hydrogen protons, which is H+, and electrons, E-. On the cathode side, it will reduce the oxygen molecules into single oxygen atoms. So from O2 will be reduced to just O. The fourth component of the fuel cell is the gas diffusion layer. Just like what it sounds like, it facilitates the transport of molecules and atoms that are required for the reaction. And it is located on the outermost layer on both the anode and cathode side. On the anode side, it will take the input of hydrogen gas, and on the cathode side, it's going to take the input of oxygen and release water. And that's all you have to know for the parts. Let's move on to how it actually works together. hydrogen gas enters the fuel cells from the anode side and will be pressurized to the catalyst layer, where it will be separated into hydrogen protons, which are more positively charged, and electrons that are negatively charged. The electrons will then be transported back to the anode and be conducted to an external circuit where it can be used as electric source, and that's where the electricity is produced. On the other hand, the oxygen enters the fuel cell from the cathode side and will be pressurized to the catalyst layer again, be separated into only oxygen atoms, so just one O. And the oxygen atoms are negatively charged because of size, and we all know that opposite attracts. So that the negatively charged oxygen atoms will attract the hydrogen protons from the other side, from the anode side, through the PEM. So remember that hydrogen protons are positive and are able to diffuse through the PEM. Once the hydrogen protons and oxygen atoms bond together, the negatively charged electrons from the external circuit that's used, like the lights already been lit, the car's already been powered, the electrons will come back and join in with the bond of hydrogen and oxygen, forming a complete water molecule. And that is how water is formed, and boom! Electricity and water are both formed at the same time in this system, and that is really fascinating. So why should we use fuel cells? It sounds so complicated. Why can't we use like fossil fuels or solar energies? Well, I'm gonna tell you later. Here are the benefits of using fuel cells. First, fuel cells can be stacked on top of each other to fit all sizes of energy outputs. It can lit a light or it can power a car, so it's very diverse. Second, the hydrogen atoms have a high energy content. That means the efficiency of fuel cell will be increased. The fuel cell have a 55% efficiency. That is a huge number compared to the solar energy's efficiency of 10 to 15%. That's really not efficient. Third, there will be no greenhouse gas emission, and that is wonderful. The climate change is happening, and we all know that. The only byproduct coming from fuel cells and hydrogen fuels is water and heat. That is really nothing compared to carbon dioxide. So after hearing so much benefits, why don't we use it now if it's that wonderful and that good? Well, I'm gonna tell you now. So first, the hydrogen fueled vehicles does not work as efficiently as the vehicles we use today. At most, it can run for about 100 miles continuously, and that does not fit our needs. Second, the companies who are producing vehicles today are not likely to support and distribute the hydrogen fuels and the fuel cells vehicles, because they already have their own vehicles that they can make a lot of money on without any big economic incentives. They're not gonna support the hydrogen cars. 3, the platinums in the catalyst of the fuel cell is really expensive, and that increases the cost of producing a fuel cell or producing a fuel cell vehicle. So that makes the vehicle less competitive to the market, and that is why the vehicles or any fuel cell technologies are not on the market today. In the end, I just want to say, no matter how hard it is, we should be all working towards the goal of preserving our whole earth, because that is our only homeland. And thank you for listening. See you next time. Bye bye.